For the relative atomic mass of the first one, we have 75%. That is 75 times 35, the atomic mass of this, plus 25 over 100 times the atomic mass of the second one, to give us 26.5. 9.25 equals 35.5. The second one, we have to find the an element composed of two naturally occurring isotopes, 9Q and 10Q. If the relative atomic mass of H is 9.68, determine the percentage abundance of each isotope. Let's assume the percentage abundance of 9Q equals 8%. And you know what? The relative abundance, the sum of the relative abundance are 100%, isn't it? So now let's assume the relative abundance of the percentage abundance of 10Q equals the one with atomic mass 10 equals X%. And X plus A equals 100%. Let's make A the subject of the formula. Let's make A S% plus A% give us 100%. Let's make S the subject of formula. X equals 100 minus A, isn't it? That is the percentage of Q with atomic number 10 equals 100 minus A%. Isn't it? Are you with me? Let's substitute. We then have A over 100 times 9 plus 100 minus A over 100 times 10 equals 9.68. That is 9A over 100 plus 100 over 100 minus A over 100 minus A over 100 times 10 equals 9.68. We then have 9 divided by 100, that gives us 0.09A plus 100 cancel 100, we then have 0.01A. Because this is coefficient here is 1, that is 1 divided by 100 is 0.01 times 10 give us 9.68. 100 divided by 100 is 1. 1 minus 0.01A. That gives us 0.09A plus 1 minus plus, let's open the brackets, plus 1 minus 0.01A. We have 10 years. Let's multiply by 10. That's 10 minus 0.01 times 10 give us 0.1. That is 0.1A equals 9.68. Collect lifetimes. We then have 10 minus 9 6 is give us 0.18 minus 0.09. I move those with letters to this side and those with just numerical value to this side. That is 0.32 equals 0.01a. I don't want to claim the question here. You then have 0.01a equals 0.32. Divide both sides by the coefficient of a, that is 0.01 divided by 0.01 equals 0.32 divided by 0.01. Then a equals 0.32 divided by 0.01, that is 32%. A equals to 32%. And recall our x is what? X is equals to 100 minus a, that is x equals 100 minus 32. That gives us 68%. So the percentage for 10q is 68% and percentage for 9q is 32%. Let me repeat myself. We are given two elements with atomic mass of 9 and atomic mass of 10. Then the relative molecular mass, the relative atomic mass is 9.68. Relative atomic mass is 9.68. Then we then assume that the percentage abundance of the one with 9 is A% and the one with 10 is X%. That gives us x plus a equals 100 and x equals to 100 minus a. That is the percentage of the one with 10 relative atom, the one with 10 atomic mass equals 100 minus a%. A over 100. You know how we calculate the first question on relative atomic mass. So we then add the percentage times the atomic mass. That gives us a over 100 times 9, and this one is 100 minus a over 100 times 10 equals 9.68. 9 times a gives us 9a over 100 plus 10 times before we multiply this 10 with the fraction, we then simplify the fraction, which gives us 100 over 100 minus a over 100 into bracket, close bracket, times 10. This 10 over here equals 9.68. Now the coefficients 9 divided by 100 give us 0.09a plus 100 divided by 100 is 1. 1 minus a, the coefficient of a here is 1. We then have 1 divided by 100, that is 0.01a times this 10 over here times 10 equals 9.68. Then we have 0.09a plus 10 times this one. We open the bracket. 10 times this one give us 10 minus 10 times 0.01 give us 0.1a, and that gives us 9.68 equals to, we collect like signs. This remove the one with letters to this side and the one with the numerical value to this side. We then have 10 minus, when you move this to this side it will turn to minus. When you move this to this side minus, to this side plus. Are you with me? We then have 10 minus 9.68 equals 0.1a minus 0.09a. 10 minus 9.68 is 0.32 equals 0.1 minus 0.09a is 0.01. 0.01 A equals 0.32. Divide both sides by the coefficients of A. 0.01 A over 0.01 equals 0.32 over 0.01. A equals to 32%. X equals 100 minus 32. That gives us 68%. Relative atom, that's the end. Example: an element X, example 3, an element X in three as isotopic forms in the ratio 2:3:4. If the isotopes have their relative atomic masses as 29, 30, and 31 respectively, calculate its relative atomic mass of element S. This question is quite different from the ones we have been solving, isn't it? That's it. That's one of the benefits of our academy. Our academy will deal with questions extensively, like difficult questions, whereby and we simplify it in a